Okay, so I forgot to do one thing, which is to introduce myself. So my name is Christopher Rigor, and I'm one of the organizers. And I have a good excuse why I forgot to do that. If you've been to a RubyConf before, you'd know that someone introduces me at the beginning, and that is Ramon, our next speaker. So it's actually an honor for me to be introducing him this time. So he has been helping out with our conferences as the MC, since the beginning. Ramon has been part of the Ruby community for a very long time. So you know him at the meetups. So I'm glad to have him as a speaker this year, and not just a speaker, but after lunch he'll be the MC again. So that takes a load off me. So thank you, Ramon. So as CTO of Bloom Solutions, Ramon Tayag leads the engineering initiatives for both Bloom's own blockchain platform and its institutional partners. An early blockchain advocate, his interests are in properly applying the technology in a practical, sustainable way to traditional industries. His experience allows him to build technology strategies that delivers the most impact within a regulated business environment. Please welcome Ramon Tayag.
Thank you, Topher. Yeah, I told Topher that I wouldn't be able to think about hosting before giving my talk. So, you heard in an introduction, Bloom Solutions deals with blockchain and cryptocurrency, and this talk really touches on a few points or a few things that I've had to think about, like writing software for applications that deal with money on servers, right? I mean, when I first got into this, I wanted to write an app that would accept Bitcoin, and then it could send it out. And then when I got down to doing it, starting a Rails app, Sidekick, because we want to do things in the background, I started to run into all these scary scenarios, like what if a job gets kicked off twice? What does it mean for the application? And it only also took 5 years for me to give a talk that's tangentially related to blockchain. So to put it into context, I guess I'll first talk about non-financial apps, and then after that, apps that handle cryptocurrency. So the non-financial apps we're most likely all familiar with. Given that example, if a job runs twice, what's the worst that's going to happen? We don't think about security so much. I almost feel like this talk is a little bit of a continuation of Sam's talk earlier, where here I'll really get into the points that I start to think about. But one tool that I found really useful was this thing called Pre-Mortem. Sam mentioned a post-mortem, and with a post-mortem, when something goes bad, you all meet and you talk about how that happened and how to avoid it in the future. You write a policy, stuff it somewhere, maybe you'll never read it again. But with the pre-mortem, you assume that something is going to go wrong. And it's a pretty powerful tool because we all don't like thinking about that something is going to go wrong. Even when doing a manual acceptance test, I don't know about you, maybe you won't admit it, but I tend to overlook so many things. I don't do these things that I kind of knew would break the system anyway, right? So with a pre-mortem, you assume that something's going to go wrong. And so let's go through this exercise with non-financial apps. And let's say an example is, I don't know, I'm going to pick a little bit of a simplistic one. A fantasy sports app, right? And let's say no gambling there. So no gambling. Pre-mortem exercise, and I'd like the audience's help here. I'm going to go through a few questions and just shout out the answer. And if you don't shout, the longer we're gonna take, and we won't end up eating lunch. So what's the worst that'll happen if data from that app leaks? Let's say you hashed the passwords, all right? So, okay, you hashed it well. But what happens if data leaks? Scores get leaked out, and personal details. Okay, sure. So, maybe the app collected more than it really should have, like it knows your birthday and your social security number.
People will know that you're terrible.
Yeah, okay, people know it's terrible. I guess, sure, bad publicity for your company. Yes, absolutely. Okay, it's getting worse. You're going to be sued. But I suppose maybe a week later, it might be forgotten about, or you'll be forgiven if you write an apology and tell the public what you're going to do. Now, let's say emails leak, right? Someone else solicits actions from the users. It's going to be a little worse. They might, they know these users exist, these emails are being used, so they might, the people that use the emails or send to them might ask the users to enter Google that's not really google.com, things like that. If someone else gets complete access to the application, well, then I guess you continue to suck, right? Your fantasy sports. So with crypto handling apps, and the example we'll use here is an application that just accepts cryptocurrency, and then perhaps later it'll pay out, right? Pre-Mortem. What is the worst that will happen if data leaks? So there's not the private key that allows the hacker to get all the cryptocurrency, but just the user information. So I'm going to shout out the personal information, right? Because here, typically when you're dealing with money, you collect a lot of information from the users. I mean, which is why there are some companies that insist on not collecting information. Right? Like you can exchange cryptocurrency and not give any personal information. And the reason they say is because they don't want to be that company that leaks data. So data leaking, not so bad. I mean, sure, it's bad. That sucks. It's like kind of like Equifax. If you have a lot of customers, then they'll make a lot of noise. But what if someone solicits actions from the users? Maybe they'll be sent a phishing email, and they're gonna send their credentials to the wrong account, and they're gonna lose all their cryptocurrency with you. What if someone else gains complete access? Well, this is pretty much what happens to the exchanges that get hacked. There's a lot to lose, and then you're going to be all over the news. So it's a big deal. Like, I ended up having to think about it like in terms of 1000x, because perhaps now when we build applications, we're thinking, no one's going to use it anyway. Or if you're hopeful, all right, yeah, sure, let's say 100, 200 people use it. That's pretty good. And then I can scale. I can work on it, I'll work on the security, I'll make it better as the application gets big. But with things like cryptocurrency, your application might suddenly become something that holds 1,000 times the value that you had planned because it got popular, or heck, maybe the price just went up overnight and you're like, okay, now I'm sitting on $1 million, right? We're in the server. And two topics, I guess, under 1000x that I'd like to talk about are best practices and decentralizing the trust. So the best practices, that's important, but I'll talk about it less. It's something we're mostly familiar with already. And this is dating advice, by the way. Kiss and be unique. Kiss is keep it simple, stupid. I first heard this in the Ruby community, but while making this talk, I found out that it was actually used in the army, where the simpler something is, the more reliable it'll be. And obviously, this joke that I hear about every year that if you want to deploy something secure, don't write any code and don't deploy anything. But that's not really going to get to our goal, right? So everything should be as simple as it can be, but not simpler. That's what this guy said. And I'm usually a monolithic, application guy, but I found that service-oriented architecture allows you to write just components that play a very specific and narrow role in your application. And it becomes easier to reason about them. And not only that, later on you'll see why a service-oriented architecture helps with security. And the be unique part, I don't know, just when writing jobs, you have to be even as simple as putting a retry false on Sidekick. That could really kill you if you're not careful with this. So database unique indexes, that helps a lot. And before you sit down and write that job, just have to think about the process. What'll happen if it dies here? Will it retry? And will I be able to recover from this? So let's take a page from cryptocurrencies and talk about the decentralizing the trust in the applications and the organization too. So let's take that example where the user deposits. Okay, make it a little smaller so it fits. Deposits, and now essentially the cryptocurrency is in an application. So now this hacker comes in, and I have to stress this because I know all of you dress like this when you're doing something devious behind the computer. Hacker comes in, takes control of your application, you're dead. Okay, you lose everything. Okay, so what can we do? I guess next best practice is you keep most of the funds in a cold storage wallet, right? Where in this example, you need 3 out of 4 people to unlock it, right? It can only accept, but you cannot pull out of it without 3 of these 4 trusted people. Okay, not bad. And then you still have a hot wallet because you want to make payments, right? You don't want to gather those 3 people every time you want to make a payment. So you have a hot wallet with less funds in it. So here you go, the hacker with the hood again. Or no, it's not a hood, is it? She comes in and gets to your hot wallet. And there's some exchanges that they didn't even have a separate hot wallet. They put everything in one wallet, and this would happen. So, okay, what can we do? So you still have that user, they want to accept, you want to accept cryptocurrencies from them. So what if they talk directly to the cold wallet, so they deposit directly there? It's one simple action. Even if that's compromised, there's some bad stuff that can happen, but the funds are kept safe, right? And this application will really be just listening to the blockchain. So it's you're kind of limiting the message that you can pass through. And then the user, also through a blockchain, gets a token back. And this is essentially what allows them to control the funds in your application. So it's right now when you deposit money into some application, your account is in a SQL database somewhere, and it says, okay, you've now deposited like 1 Bitcoin or something like that. But that could be changed, right? If the hacker gets into that, that can be changed. So that's something that, if possible, we'd like to decentralize a little bit. So what if you use a blockchain in the middle, because you see those little rings, those nice pictures of blockchains there. What if you use the blockchain in the middle as a message passing system that essentially, it doesn't replace your application, but you're almost never talking directly to one another. So you can put like a firewall or something like that, even between applications. You could do something like that. And so when the user wants to withdraw, they send that token out, gets maybe to the hot wallet, and the hot wallet can send the real crypto back in. We've talked about software. And the software, we've like broken it up from one application, it became multiple, and then even that main application that the hacker would have previously gotten into is no longer there. You still have to worry about, well, the team. There's not really software anymore, but like the team that's running the operation. So with this cold storage, I guess, it can't. This is the best I could think of, like multi-sig, where you need 3 of the 4 people to collude in this example. But this hot wallet, I mean, if the hacker somehow still gets to that, in one exchange, it was an employee that did it, and this wouldn't solve the problem. But what if you had split that into more applications, and each had their key, and they both had to agree on what the blockchain says, and they both accessed that. Finally, one thing that I find a little disconcerting, I guess, about the exchanges today is that you can't tell that the Bitcoin they owe to people is actually something that they have stored, right? Like they have in reserve. They might tell you that, yeah, we're full reserve here, but really you don't know that. But by using blockchain technology and signature and public key cryptography, you can begin to prove these things. And by aligning incentives, I think this is an important part. It's like you're continually thinking about being transparent with the user. It's like putting the rules out in front and not being like dodgy about it, putting them out there, saying this is what we're going to do, and then you continually live to that expectation. So a few closing thoughts. This is probably overkill for many of the applications. It'll be good to get the low-hanging fruits. You do those things first. Think about like what your application might deserve, what kind of security it might deserve. Is it like just 10x of what you're thinking? Perhaps 1x, 100x, or 1000x? What are you handling here? What's the worst that could happen if ... And one thing I found to be useful was when there's a weak point, you can attempt to decentralize that. Like break it up into pieces, have perhaps different people manage it, different applications that need to agree on a certain action. And the last one is that I'm always going to miss something, so always be paranoid. And that's actually not a bad thing, because it'll make you keep asking that question, like, what else did we miss? What's the worst that'll happen? Pre-mortem. That's it. Thank you. Yeah, the floor is open for questions. You don't have to shout anymore. I think there are mics and perhaps people. Yes.
So I'm curious, doing development with blockchain, what happens if you develop something you make a mistake?
So what happens when you develop?
Roll back.
Yeah, what happens when you develop something, you make a mistake, and you can't really roll back? Well, I don't know, you tell me. I mean, that's what the pre-mortem is about. Like, it's trying to avoid that situation where, well, one, of making the mistake, right? But you assume failure, so if the mistake also happens, how do you recover from it? Or when, rather, when the mistake happens? Yeah. I find it a very useful tool to use, this pre-mortem. And, well, that's it, actually. Yeah, I wish I had an excellent answer for you, but, this is a learning process as well. I'd like to hear from people who are more into security too, actually. Okay. Steve has a question.
Split it up, decentralize your apps?
Yeah, well, there's some apps that would know about certain things, like that the cold storage app would know about deposits, but not really withdrawals. Yeah, and then the hot wallet would know about the withdrawals.
This isn't a financial app that I'm working on, but it's something where you have a choice. You can pile it all together, or you can basically clone the same app in many instances. And I took the decision to chop it up, so that compromise of any one app does not lead to disclosure of your entire system. And the clients got it right away.
Oh, cool.
They're like Equifax. I'm like, yeah, you're not going to have an Equifax moment.
Yeah, yeah. And I guess the problem is that there's more development work to do, right? And it's the balance there. Yeah.
The tools today to do this are much better than they were years ago, managing multiple instances and all of that.
The tools today are much better than they used to be. Yes, absolutely. Like, I just started playing around with Kubernetes maybe a year ago, and I was like, wow, I can't imagine like having to do this any other way.
But as far as paranoia goes, are you sleeping all right with this?
For now.
For now. Thank you.
Yeah, thanks. All right, thank you.